guys, and welcome once more to this new video on my YouTube channel, where actually we are going to be solving question 3 of June 2022 pure mathematics with mechanics paper 3. So the question reads: sphere A of mass 2 kilograms moving with speed 4 meters per second along a horizontal smooth surface collides directly with sphere B of mass 8 kilograms initially at rest. Given that the coefficient of resistance between A and B is R, calculate A. the velocities of A and B after impact and comment on the result. B. the magnitude of the impulse experienced by A during the impact. And C. the total loss of kinetic energy due to the impact. So let us then move into the solution and some brief important analysis or concerning this question. Actually, that is the solution of this question. So when solving a mechanics question, actually, the first thing which you have to have into mind is that you should first of all try to figure out what is happening. Since we are on direct impact and momentum, it means here concerning this question, actually, we have to consider 3 events for this question. Actually, we have to consider the event which happens, that is, since A goes and collides directly with B, so you have to consider the event which happens actually before the collision. Actually, we have to consider the event also which happens during the impact, okay, and we have to consider the event which happens actually after impact, okay. So what happens then before the impact? So before impact, we have been told that sphere A and sphere B actually are on a smooth horizontal surface. Sphere A, okay, is moving towards B, that is going towards B, okay, for direct collision to occur actually. And sphere A is moving with a speed of 4 meters per second, okay. It is moving towards sphere B actually, which is stationary. And since sphere B is stationary, it means the speed of sphere B before the impact is simply going to be 0 meters per second, okay. Then what happens during impact? During impact, both sphere A and sphere B experiences impulses, okay. That is, sphere A and sphere B, both of them are going to experience impulses. That is, sphere A is going to experience an impulse, which is in this case GA, and sphere B is going to experience an impulse, which in this case is GB actually. And finally, what happens just after impact? After impact, sphere A, okay, is going to move a velocity. Let us call this velocity VA, and sphere B is going to move with a velocity. Let us say that velocity. Let us call that velocity VB. So in the A part of the question, it's simply asking us actually to determine these values. That is the values of VA and VB. Actually, that is the A part of the question is asking us to determine the velocities of A and B after impact, and we are also asked to comment on the result. Okay, yes. So to get the velocities of A and B, okay, after impact, yes, actually we have to take note of 2 important big principles in these questions involving actually direct impact and momentum. We have to know this principle. That's the first principle. That is the law of conservation of linear momentum, and you have to know the Newton's law of restitution. Once you know those 2 laws, you can therefore form 2 equations with both of those laws. That is one equation, okay, from the law of conservation of linear momentum, and the other equation from Newton's law of restitution. And at the end, we simply calculate those 2 equations simultaneously actually. So from Newton's law of restitution, or from the law of conservation of linear momentum, excuse me, which says that what? The momentum before collision, okay, is equal to momentum after collision. Okay, so what happened then? What then the momentum before collision? Momentum, you know, the momentum is actually the mass times the velocity actually. Okay, that is before impact we have this actually. That is before impact we have ma, okay, time before impact. The momentum before impact equals to the mass of A times the speed of A, okay, before impact, plus the mass of B times the speed of B before impact. Okay, this is the momentum before collision. And after collision, we have the momentum after collision actually, which is equals to the mass of A times the velocity of A, okay, after impact, plus the mass of B, okay, times the velocity of B after impact. Yes. So actually, since we already know the value of ma, that is the mass of A, okay, we know the mass of B, we know the speed of A before impact, that is 4 meters per second, and we know the speed of B before impact, which is 0 meters per second, since sphere B was at rest, that is was initially at rest. So replacing those values, we are going to get 2 times 4 plus 8 times 0 is equals to 2VA plus 8VB. Simplifying this, we are going to obtain 2VA plus 8VB to be equals to 8. Dividing both sides of the equation by 8, we are going to obtain 1 quarter VA plus VB to be equals to 1. And let us call this our equation 1 actually. Okay, yes. So from Newton's law of restitution, actually, that is, there's a formula from Newton's law of restitution actually, which is what? Which is VA minus VB divided by UB minus UA to be equals to E, where E is a coefficient of restitution between the two spheres. Okay, somebody else could put UA minus UB in the denominator and include a negative here. It will still give the same result, but me, I decided to use this formula actually. Okay, yes. So knowing already the value of UB to be 0 meters per second and the value of UA to be 4 meters per second, we are going to obtain this, that is VA minus VB divided by negative 4, which is equal to a half. Simplifying furthermore, we are going to obtain VA minus VB to be equal to negative 2. And then since we already have this our two equations, that is this equation which we obtained from the law of conservation of linear momentum, okay, and this equation which we obtained from Newton's law of restitution, we can then solve these two equations simultaneously, or we can, yes, simultaneously. So adding the two equations, that's equation 1 plus equation 2, we are going to see clearly that the values of this VB are going to cancel. It's going to cancel, okay, actually. So this VB is going to cancel. We are then going to obtain 1 quarter VA, okay, plus 1 quarter VA plus VA, which gives 5 over 4 VA to be equal to 1 plus negative 2, which is going to give us negative 1 actually. We therefore imply that our value of VA, that is the velocity of A or sphere A actually after impact, is going to be equal to negative 4 meters per second. And it is simply here that our comment comes into place. Why? Because we obtain the velocity of A, okay, after impact to be negative. And since the velocity of A after impact is sphere A is negative, okay, after impact, it implies when A, okay, after the collision, okay, that is when sphere A collides with sphere B, that is after the collision, sphere A is actually going to move in the opposite direction, okay, to sphere B actually. So saying that implies sphere A, okay, moves in the opposite direction, okay, to sphere B just after the impact, okay. Reason why we have this negative sign here actually, yes. So since we already have our VA, okay, that's the velocity of A after impact, okay, we have the velocity of sphere A after impact, we have the comment already, so it is just left for us to determine the value of VB, that is the velocity of B, okay, after impact, the velocity of sphere B after impact actually. We can simply substitute the value of VA into equation 2, that is into this equation 2. We are going to obtain VB to be equal to 2 minus 4 feet, which implies that we are going to get the value of VB to be equal to 6 all over 5 meters per second actually, which is therefore the velocity of sphere B after the impact actually. Okay, yes. So actually we can then move actually to the B part of the equation, which says that we are being asked to calculate the magnitude of the impulse experienced by A, okay, during the impact. So the impulse experienced by sphere A actually is simply GA, as represented on the diagram which I showed previously. So the value of GA is simply equals to the variation of the momentum of sphere A, that is GA, which is the impulse experienced by A, is going to be equal to the momentum, okay, of sphere A after the collision, that is after impact, minus the momentum of sphere A, okay, before the collision actually, yes. So we only have the value of MA, we only have the value of VA, and we only have the value of UA. So simply replacing those values into this formula, we are going to obtain GA to be equal to 2 times open bracket negative 4 feet minus 4. We are going to obtain the value of GA to be equal to what? To be equal to negative 48 divided by 5. But since we are being asked to get the magnitude of the impulse experienced by A during the impact, we are then going to obtain GA magnitude to be equal to 48 divided by 5 kilogram meters per second. Always include the values, the units actually, very important. Yes, so we are then going to move then to the C part of the question, which are asking us to determine the total loss of kinetic energy due to the impact actually. So Simply here, what you have to know is simply the formula to get the total loss in kinetic energy, which is equals to what? The total initial kinetic energy minus the total final kinetic energy, actually. Okay, yes. So we simply have to determine the total initial kinetic energy and the total final kinetic energy, and at the end we simply make the difference, okay, between the two. We are going to obtain the total loss in kinetic energy. So the total initial kinetic energy is simply the kinetic energy, simply the sum of the kinetic energy before impact. That is the kinetic energy of sphere A before impact, okay, plus the kinetic energy of sphere B before impact. Okay, we are going to obtain this. Wherefore is the speed of sphere A before the impact, and 0 is the speed of sphere B before the impact, since sphere B was actually initially at rest. We are never going to obtain the total initial kinetic energy to be equal to 16 joules. Similarly, we have to obtain the total final kinetic energy. So the total final kinetic energy is equal to, as I said, the sum of the kinetic energies, okay, that the kinetic energy after impact, okay, which is actually the sum of the kinetic energy of sphere A after impact plus the sum plus the kinetic energy of sphere B after impact. Knowing that the velocity of A actually, okay, before impact, after impact is equals to -4 feet, and the velocity of sphere B, okay, after impact is equals to 6 divided by 5. We are going to obtain therefore the total final kinetic energy to be equals to 6.4 joules. Now getting then the total loss of kinetic energy, okay, due to the impact to be equals to 16 joules, that is the total initial kinetic energy, which is 16 joules, minus 6.4 joules, which is the total final we are going to total loss in kinetic energy is going to be equal to the total initial kinetic energy, which is equal to 16 joules, minus the total final kinetic energy, which is equal to 6.4 joules. Okay, therefore we are going to obtain therefore the total loss of kinetic energy due to the impact to be equal to 9.6 joules. Thank you very much for watching this video, and remain tuned for a next interesting mathematics video concerning mechanics. Thank you.